So the access modifiers in Java are basically a little bit of a history on access modifiers is when object-oriented programming came along, or before object-oriented programming, all methods and variables were considered public, meaning any part of the program can touch any method or any variable. So when we wanted to talk about parts of classes, which would be methods or data, came along with the idea, and this kind of originally showed up in C++, maybe languages similar to C++ just before then, had the idea that we can have methods and variables that are declared as public, meaning outside of that class they can be accessed. Then the idea was we may want to have some variables that are used for computations internal to the class, or methods that are used only by other methods within the class, but should not be accessible to the outside world. And we decided to make those private. So when we have private methods or private data, then it cannot be accessed outside of that class. So then the issue of if you were to inherit from a class, and it had private data or a private method, should that be inherited? And the issue with inheriting private fields is a class could inherit it and then turn it public, and then they would have access to it. So the concept of making something private, blocking anyone else from seeing it outside of the class, would go away if we were allowed to inherit private data. So then the question is, what if you wanted to have data that should be private, data or methods that should be private, but you would allow it to be inherited? So you'd like it to be private so that code outside of the class cannot use it, but if somebody wants to inherit from your class, they would get a private copy of it. So decided to create, in C++, they decided to create an access method called protected, which basically means it acts like it's private, but it can be inherited. So Java builds off of this. Java allows you to put one of these three modifiers in front of any data or any methods in your class. And it also allows you to leave it out. And if you leave it out, it's, the modifier falls into a fourth category called a default, meaning you left it out. So the private access modifier is the least generous modifier. Top-level classes, not counting inner classes, may not be declared private. Otherwise, nobody could access it. A private variable or method may only be used by an instance of that class. It cannot be used anything outside of an instance of that class. Once you go outside the class, you can't use any method or data that is private. So it's really used for internal computation within the class. And then if you do not specify a modifier, you actually get it gets considered, this is not a keyword, default is not a keyword, but is considered to be in default. So default means you didn't specify it, and what this means is that the name is the name is used to access the class variable method if you don't specify a name. Class data and methods that are default, as well as the class itself. Class default features are accessible to classes that are in the same package. So this would be a good time to just kind of go over a little bit of a history of the concept of Java packages. So the idea of private variables are that anything outside, any class or code outside of your class cannot access anything that's private. But you might see that there could be times when two particular classes, or maybe a set of classes, you might want to have a design where they can access each other's private data and private methods. You might say two particular classes that for some reason work in conjunction with each other. They should be allowed to access each other's private data and methods. So the way C++ handled this was they allowed classes to declare another class as one of its friends. So there's a friend keyword in C++, and you say class A is a friend of class B. And the friendships were actually in one direction. If B wanted to access A's default and A wanted to access B, each one would have to declare each other friends of each other. So it's kind of like Facebook. You're declaring yourself friends and then you have access to each other's private data. When Java came along and said, okay, since we're going to be grouping packages, classes together, and saying this group should have access to the private data and methods of each other, rather than have a big network of individual classes declaring who all their friends are, Java came along with the idea of taking classes and grouping them together into packages, and anything that's in the same package is what C++ would now consider a group of friends. So the idea of a default, the default modifier, if you don't specify on a method or a piece of storage, you don't specify private, public, or protected. You leave it out, it's considered in the default state. And the default state means that access is given to any class that is in the same package that you're in. So it would be kind of like it's private, but it's shareable to your friends. And your friends are any class that are in the same package as you. The protected modifier gives more access than default. So default allows, like I say, default is kind of like a group of friends in C++. And protected is not only is the private data accessible to all the other classes that are in the package, which means they're friends with each other. It's also accessible to any class that inherits from this class. So if a variable is called protected, if it's modified with the access is protected, that means any class that's in the same package as the class you're in, or any class that inherits from the class, will get a copy of this data. And its status in the inheriting class will also be protected, which means it can be passed down to another class that is inheriting from it too. And then the public modifier is basically the way C and the older programming languages work. Every piece of storage and every method is accessible anywhere in the program. Okay, so as far as overriding variables and methods are concerned, the question is, would it be a good idea to have a private variable overwritten by a default variable, or would a default variable, would it make sense to override it by a public variable? So the thing is, any private variable or method could override anything it inherits. Well, first of all, it can't inherit anything private, but it can override, if it's inheriting from a class, it can override any of the, anything that inherits. It can be overridden and made private. So for example, if you inherit from a class, and it has a public method called, count customers or something like that, you can override that method and make it private. So what effect would that have? If you inherit, so suppose you have a class and you inherit a public method. So you get a copy of that method and you decide, oh, I want to write a better version of it, or maybe the same version of it. But you make your overridden version private. Now somebody creates an object of your type. Can they call this method? You inherited a public method, but then decided to rewrite it private. What have you effectively done? Does the question make sense? You inherited a public method. You inherited a public method. And then, you know how when you inherit something, you get a copy of everything you're inheriting from. Anything that's public, of course, you're going to get a copy of. Anything protected, by definition, you inherit. Anything that's default, you wouldn't inherit it, but you would get a copy of it if you're in the same package, same group of friends. And private, you won't get a copy of. So if you inherited, let's say, a method that in the base class was public, you inherited it, and then decided to rewrite it and make it private, what would happen? If somebody created an object of your class and then tried to use that method. So when you overwrite it, you're saying use my version, not this version, if it's called an object of your type. And if you made it private, you make it inaccessible. So what you've effectively done is gotten rid of something. So that's one way to get rid of stuff. If you inherit from a class, right, you get all its methods and all its data. Suppose you're looking at it and saying, I got to get rid of a couple of things. The way to get rid of it is rewrite it, overload it, and make it private. And then nobody can access it outside of your class. So private may override anything that any category of the data or classes, data or methods it's inheriting. Default can override default, protected, and public. The reason it can't override private is because it doesn't inherit it, so it's not even there to override. Protected can override anything that's protected or public. Something that was default that came into it, it couldn't upgrade it to protected. And public may only override public. So what is the idea, what do you think is the reason that you can't inherit, let's say, a protected method, which is effectively private but inheritable? You can't inherit it and then override it and make it public. What would be a reason the compiler wouldn't want you to do that? Like, in other words, why do you think this is not allowed? I'm sorry, why do you think that you can't, public cannot override a protected method?
It could be a security.
Yeah, so whoever designed the class and made a field protected doesn't want the outside world getting access to it, but will let you have access to it if you inherit from it. Then you inherit from it and turn it public. Now it's available. You can take an object of the type that needs it to be protected, cast it to your type, and then you went and made it public. So you could give away, right, so this would only make things more restrictive. It should never make things less restrictive. So that's as far as overriding is concerned. And then other, kind of random modifiers. So modifiers, basically when you declare a method, a class, or a variable, you put words in front of it, and that basically restricts its use. So the final modifier has a couple of meanings. Depends on how it's used. But a final class, if a class is declared as final, it cannot be inherited from. You couldn't extend it if a class is made final. So for example, if you said if you made your own class called submath, which extends Java language math. So Java language math is a class that has a bunch of functions in it, like how to calculate the square root and the area of a circle and all that stuff. And you decide, I want to make a class, I'm going to take everything that's in here and then I'm going to add some more stuff. So I'm going to make my own class called submath, and I'm going to extend it. This will have a compiler error, and the reason is the creators of the Java language math class made that class final, meaning nobody can come along and inherit from it. So when you make a class final, that means nobody can inherit from it. They'll get a compiler error if they try to inherit from it. A final variable is a variable that cannot be modified. And this was called a const, C-O-N-S-T in C++ programming language. So in C++, if you said const float pi equals some value, nobody could come along later and change it. But in Java, instead of using const, they use the word final again. So a final float pi equals 3.14. If you put this in your program, and then later on you use pi, and you're wondering, oh, did somebody change pi to like a value that's not pi, and it's going to screw up your calculation, you can be rest assured it won't be changed. So no one can change whatever pi is, because it was declared as final. If somebody later said pi equals 6, they're going to get a compiler error, because they're trying to change a constant variable. The other thing is this takes up less space, because we don't have to allocate storage and then put 3.14, the runtime environment doesn't have to allocate storage and put 3.14 in it, and then anytime somebody uses pi, we have to go out to that storage and get a copy of its current contents. The compiler can just read this, and anywhere pi is used, it can just put in 3.14, because it knows it will never change. And then we can make a method final. That means the method cannot be overridden by an inheriting class. So, for example, you can say a final float circle area, you give it a radius and it will return pi r squared, pi times r times r. So what you don't want is somebody to inherit this method from you, create a class, they would get a copy of this, and then they'd say, oh, I know better, I know a better way to find the area of a circle, and then they go and use some formula that's not correct. So you could put final in front of a method that just says, you can inherit from my class, but don't overwrite this one. This is the last and final copy of it. You can't make a new version. Okay. Then the abstract modifier, we've used this one before. You can use this on classes and methods. So an abstract class is a class that cannot be instantiated. So for example, you could say abstract class, and then let's say electronics, which is a vague concept. And you could describe things that electronic components, electronic products have in common, and then when you go and make the actual electronic components, like watches and clocks and radios and stereos and DVD players, they would actually be the real things that you would instantiate. But if somebody came along and said, I want to create an object of type electronics and generate one, this would not be allowed, because it's an abstract class. Abstract methods can exist inside of a class, and an abstract method contains only a signature, no body. So for example, you could say abstract void and power up, but it doesn't have a body to it. So what that means is if anybody was to inherit from this class, they would be, you always have the option to overwrite the method. This, now that you have an abstract method, you would now be required to overwrite the method. So if you think about it, if there was a class that was not considered an abstract class, but it did contain an abstract method, would you allow a programmer to instantiate an object of that type? Or would there be an argument against that? So in other words, what we're saying is, if you had a class, so we can have classes, you could say the class is abstract, that guarantees nobody will ever instantiate it. Or you can have a method that is abstract, maybe the class is not abstract. So if you had that scenario, if you had an abstract method inside a non-abstract class, and somebody wanted to create an object of that type, is there a problem with doing that? An abstract method would have no body to it. If someone created an object of that type, they should be allowed to call the method, and the method doesn't do anything. And so one choice is if you call the method, it doesn't do anything. And then the other choice is to say this should not be allowed. So in Java, they actually require, if you have an abstract method in a class, you're actually required to declare the class as abstract. So an abstract class should have at least one abstract method in it. If every method was defined, you almost might want to consider making it non-abstract. But you could also make it abstract just to prevent somebody from instantiating from it. And then there's also the concept of a static. So static basically means, static is for variables and methods. So a static variable means that there can only be one instance of that variable per class. So you could have object data. So an example could be something like we were saying with our electronics example. In our electronics class, we can have a static variable called, let's say, serial number. So every product we make gets a unique serial number. So we'd have only one serial number, and then every time we create a new product, we just increment the one and only serial number by one, and then assign that over to an object variable. Or we could also have a counter of how many products we've made. We could have a variable called number of products made, and every time we make a new one, in the constructor we increment that number by one. So it'd be a variable shared by every instance of the class. And then a static method is a method that cannot implicitly alter non-static data, object data. Unless it had a reference to a particular object of the class, then it could reference it. But other than that, it's only meant for accessing static variables. So we have static methods to handle the static parts of our classes. Okay.